watching this didn't have a question with checkpoint number 6. If they do, it's in the OneNote class notebook file. I know it's not written very beautifully, but I'm not going to erase it. It'll stay there. Okay, so good job for remembering to remind me to turn the recording on. All right, so that was the only checkpoint. Was there any other checkpoint question that you guys wanted to go over besides that number 6? Perfect. Okay, so let's head into day 16 then. All right, so day 16 was like an intro to the study of math called combinatorics, which is basically just combining different things, right? It basically is what it sounds like. But it definitely falls into this whole category. As you'll see when we start talking about combinations and permutations, it uses factorials, and the binomial theorem actually steals the combination formula. So it all kind of ties in together. But yeah, so for the first day, there were questions on the dice problems, and then there was a question on, I believe, number 12. Number 12, yeah. Okay, so just scroll down here. There we go. Okay, so for the dice problems, some of them were pretty straightforward. Number 3 was definitely the toughest one on here. Now, don't worry about number 3. It definitely is challenging, and I don't, there's not going to be anything like that on the checkpoint. It was just kind of like, I don't know, like one of those problems that you just want to think about. But the main idea here is that you have 2 different dice, and so you want to kind of figure out how many different ways you could roll these different outcomes. So what I like to do when I do mine, so I know Miss Marker kind of has hers like where she does it kind of horizontally, where she says like dice 1, and then she says like how many outcomes for the can you roll for the first dice, and like dice number 2, what are the outcomes for the second dice. I like to do it with like dashes. So just if we're looking at one, so I know number 3 was definitely tough. I'm going to kind of skip number 3. I'm going to look at number 1 really quick. It's the most basic one, but it kind of gives a good idea of what's happening here. So if we take 2 6-sided dice and we roll them, so for each one of my events, I would do like a line. So like this first line is dice number 1 times my second event, which is dice number 2. So dice number 1, there are 6 different numbers that can happen when I roll the dice. So there are 6 outcomes when I roll the first dice. Since it just wants me to figure out how many different combinations there are total, right? It doesn't matter what the second dice rolls on. It could roll on anything. So I have 6 more options for the second dice. And then you just multiply and you have 36 total outcomes. Now, this would be more of a permutation way of thinking, because I'm saying that if you roll dice number 1 rolls a 6, dice number 2 rolls a 3, well, that's different than dice number 1 rolling a 3 and dice number 2 rolling a 6. So I'm saying the order that you roll them in kind of matters. You didn't have to think about that for this one. I just wanted you guys to say, oh, there are 6 things that can happen with dice 1 and 6 things that happen with dice number 2, so total 36. And so I think most of these are pretty similar. So let's see. Miss Margaret, I know, did number 4 with you guys, well, like in the video. So let's just do number 2. Let's just look at number 2 and see what we have. So number 2 says, how many ways can you roll an even number? So we're thinking like sum, like can they add up to make an even number? So again, so we have 2 different events. We have dice number 1 and we have dice number 2. That's our second event. So the first dice, you can roll anything. So any number, whether it's even or odd, can add up with something else to make an even number. So you have 6 options. All right, well, then you have to think about, okay, so I have 6 options. What if it lands on an odd number? Well, then you can only have a second odd number to make it an even, right? Because an odd plus an odd makes an even number. So if you then think about your dice, how many odd numbers are on your dice? Well, there are 3 odd numbers on the dice. Okay, so 3 odd numbers. All right, well, same thing goes with even. So if you roll an even number on the first dice, you need another even number on the second dice in order to have a combined total of an even number. So how many even number are on the dice? Well, there's 3. So the second dice can, once you roll your first number, the second dice can be either the 3 odds or the 3 evens, depending on what the first one was. So the second event, there are 3 options. So total, 6 times 3, 18. All right, so that one's these ones are definitely very, I don't know, you have to kind of think about it a little bit, but they're not too, I don't know, they're not too bad. You can if number 3 was the one that gave you a hard time, just ignore number 3. It's tough. There's like lots of different parts to it. You guys won't see one like that. It went better with some stuff that we were going to have in this unit originally, like if we would have been in school. But since I kind of took that other piece out, we don't really need to worry about ones like number 3. Okay, the next one you guys wanted to go over was number 12. All right, so these were the ones that we kind of added because, again, there's a lot of stuff that we kind of cut from this section because we're doing it kind of, at home by ourselves. And some of it gets really weird if you're not like in class together talking it out. So we kind of cut some, but then we kind of found these and added them in. So I actually don't even have answer keys I like physical copies of it where I'm like looking at it. But we'll go through this one. So it says, how many 4-digit odd numbers can be formed if no digit is repeated? How many 4-digit odd numbers can be formed if no digit is repeated? Okay. That one's super easy. Okay, so first off, we have 1, 2, 3, 4. So we have 4 different digits, right? How many 4-digit odd numbers can be formed if no digit is repeated? Okay, so this one's a little tough. All right, so we have 4 digits. All right, so I made 4 lines. All right, so the first digit, it can be, we'll say it can be just about anything. Actually, let's start with the end digit. Start with the last one. So, which usually I don't usually start in the backwards order, but think about what makes a number an odd number, right? It's the very last number that you have is what's going to make it odd. So I want to get the most amount of odd numbers possible. So this number right here, this is what's going to make my number an odd number, right? So how many odd numbers are there so our digits are 0 through 9. So looking at 0 through 9, how many of those are odd numbers? Well, 1, 3, 5, 7, 9. So we have 5. So there are 5 numbers that we can have here that would make it an odd number. Well, it says we can't repeat any numbers. So if we have 5 options that make it odd. Now let's say we use one of those numbers. Well, the 3 other numbers left, they can be anything. It doesn't matter if they're odd or even numbers because it's not going to affect our problem being an odd number. So we'll say that we've used up one of the odd numbers at the end. So then the next spot would only have, instead of, so it starts with, there are 10 digits between 0 and 9. Yeah, so it starts with 10. So 1 is now being used up. So we'll say we only have 9 numbers left for that next number. All right, so because we're not allowed to repeat. So then once we use up a number in that block, we have 1 less number to go in the next block. So we would only have 8 numbers left. And then the next block, we would only have 7. So that's how I would do the problem. So then you just multiply 7 times 8 times 9 times 5.
Miss Lassie?
Yes.
When you're counting 7 in the first digit,
Yeah.
wouldn't that mean you could possibly put 0 there and it wouldn't be a 4-digit number?
That's true.
Colin.
I know these ones are, yeah, but you could have used up 0 in either spots 8 or 9, but we don't know if we used them up.
That's true.
Yeah. See, I hate these problems. This honest, if we're being, and this is dumb to say because I'm making you guys do it, but this is by far my least favorite unit that we have to cover all year. Because probability, like I would never would have even have thought of having 0 in the first spot, because 0 could be either spots 8 or 9, but it couldn't be the first one. I don't know. How do we? I don't know. I don't know.
When I did this, I had 8, 8, 7, 5.
8, 8, 7, 5. Did you start with the front?
I did start with the front.
Yeah, but what? So, like, yeah.
Can you just subtract 1 for that edge case? Because since it can't repeat, you could. It's just that one case where 0's in that one spot.
Yeah, you probably could. You probably could subtract that 1.
Wait, hold on though. It wouldn't count if 0's in the first spot because that's technically only a 3-digit number.
That is the problem. That is the problem we're trying to think of right now. I don't know. Maybe I'll Google it. Maybe I'll Google it at the end of this thing and see if I can figure out the answer for it.
Well,
I'm sure there's an answer. Yeah.
if a zero doesn't count as part of the number if it's in front, does it?
That's what we're thinking.
Yeah.
Right. But the problem is 0 can still count if it's in spots 8 or 9. It just can't count if it's in the first spot or the last spot, right? Because it's not an odd number. So how do you get rid of 0?
Does that mean the first digit could be 6 or 7, right? Can either be two answers?
There totally could be 2 answers, right? Because it could either be this. So 7 times 8 times 9 times 5. The only problem with this is you're right. 0 can't be in the first spot. So we would also say, we could say like, I don't know. It's probably a combination problem where you have to do like 2. There's like, I'm sure there's some kind of subtraction probably.
Isn't Miss Market's answer 8 times 8 times 7 times 5?
8 times 8 times 7. Yes. That's what she said it was. I don't know.
Because if you start with the first part there, you leave off 0, so you can't choose 0, so you have 9, and then you can't choose the last digit, so you have 8 options there. And then you have 8 in the second spot because you can't choose the first number and you can't choose the last number or the last digit. And then you have
0.
But you can choose 0, and then you have 7 because you can't choose the 3 digits that have already been taken. And then you have 5 in the last one because there's only 5 odd numbers.
So we would say 8 for this. So 1, 2, 3, 4. We're just working this out together, guys. It's like some class team building right here. All right, so
Can you say the
don't know
reasoning
how to do
behind that again?
combinations. So the first spot, we can't have the last digit. We can't have 0. So that's
Hold
why
on.
Yeah, hold on.
9987 would make sense to me.
998. Well, definitely the last blank can only be 5 because there are only 5 odd numbers.
Hey, oh shoot, I forgot about the odd part.
Right.
My bad.
Right. If it wasn't, if we didn't have to worry about the last number being odd, then it would be easy. It would be what, 9 times 9 times 8 times 7. That one would be, because the only thing you have to eliminate is having 0 as the first number. So that one would not be bad, but then we have to watch out for odd. So yeah, I think I could go with 8 because we can't have 0 and we can't have the last number. We know the last number has to be 5 because there are 5 odd numbers. So yeah, so 8 and then 8, because that one is not the first number, not the last number, but it can be 0. So it gets 8, and then this would be then 7, 8, 8, 7, 5. I could vibe with that.
That makes sense to me.
Yeah, I feel that.
Wait, can you say one more time why the first one is 8?
Okay, so the first number.
Because of the last digit being 5, I thought.
Well, so there's 2 reasons. So there are 10 digits between 0 and 9, right? So 0 through 9, there are 10 different number options. All right, so normally we would say there are 10 options for the first digit, but the first digit can't be 0. So that drops the first number down to 9 options. And the first digit can't be the last digit, which has to be an odd number. So that drops it down another one. So that means there are only 8 possible answers for the first block. So then the second block, so normally it would be down at 9, or it would be down to 7. But we can add 0 back in, which jumps it up to 8. So that's why we have the double 8 there. And in the 7, it gets -2 from the first boxes, plus it can't be the last number, which has to be an odd. Yeah, I like that. 8875. I can vibe with that.
Could the first number be negative?
Well, it doesn't matter. This is just, it's not negative, wouldn't count as being like part of a number. It wouldn't count as part of a number. This is just saying, like, bringing in negatives brings in like different things. Like when we're talking about like just digits, we are just looking at number values. Negative would be something that would be like in front of the first number kind of thing. So we're not really counting it as being a thing, as doing negatives. It's just, we're just looking at the digit combinations. Negative brings in a whole different thing to it. Don't think that hard. Like, could negatives. Don't go that hard. Yeah.
Right.
I think that's good though. I think I can get behind 8875. I probably am still gonna Google it later. These just don't sit right with me. Like, these are the worst. That's why I like permutations and combinations, because there's rules. I don't know. We'll talk about those when we get there. So I would probably have I would have probably accepted either of these two answers. So usually when we do this like test, my answer key usually has multiple answers, especially like, I mean, you guys are just doing like, for the most part, it's going to be multiple choice checkpoint. But when these are all like short answer when we do them, especially if there's like a lot of work shown, I can be easily persuaded to just believe that if your work makes sense to me, that you did it correctly, even if it's nowhere near what I did on my problem. It's just, this is a hard unit. Jane, you're here, probably. Last year, this student named Max, which I'm sure most of you guys know who Max is. Maybe you know who Max is. Anyways, he always had a way of thinking out the problems in ways that I never would think of them. And so I just had to sit there half the class and just think about the problem that he did. And I'm like, how did I not think of that? I don't know. This is an annoying unit for me. It's not my favorite. This part right here is not my favorite part of math. I didn't excel at probability and combination and combinatorics. It's okay. We all have our downside. All right. So I would have taken both of those answers probably for number 12. I think they both kind of make sense.
Could you explain the second one again for 12?
240. What the one that I have kind of written in 13's box?
No, the 68951.
Oh, this is not anything. This is just what somebody said, and I was like thinking about if it made sense.
Oh, okay.
Yeah, that's not my thing. Yeah.
We have a comment that people need to be let into the meeting.
Okay. All right. Sorry, I can't see that screen anymore. It's all like. All right, I admitted them. It was just 2 people. It's fine.
No.
Should have been on time.
Is there somebody choking?
It's just Ben. He's fine. Okay. All right. So that was fun. Those.
Yup.
Like,
My dumb mic.
yes.
Right,
Ben.
I turned off.
Yep, I know. I turned it off. Just turn your mic off when you're not. Yeah, just turn it. There you go. We're off. Okay. All right. So that was the only ones we had for day 16. Are there any other ones you guys want me to do with you guys, show you how good I am at combinations. Perfect.
I
Cool. Okay, Jake, what do you want?
Can you do 13?
Yeah, sure. We'll do 13. It'll probably be just as fun as the other ones, the last one. All right, let's see. I hope this isn't a bad one. Let this one be straightforward. Okay. Ooh, license plates. Usually I'm pretty good at those ones. Okay. So the standard configuration for an Alaskan license plate is 3 letters followed by 3 digits. Okay. So I would start by doing this. So 1, 2, 3. These have to be letters, followed by 1, 2, 3 digits. So these have to be digits. How many different license plates are possible if letters and digits can be repeated? All right, so we'll do that first part, and then the second part says cannot be repeated. Okay, so for the first part, if we can repeat, so the first thing you have to ask yourselves is how many letters are there in the alphabet? There's 26. Fun fact, there used to be 27, but the ampersand, the and symbol, used to actually be in the alphabet, but it's not anymore, and so we only have 26. I learned that the very first year when someone told me that there was 27 letters, and then I told them they were dumb, and then I Googled it, and I was like, well, technically there used to be 27. All right, anyways, so for the first blank, there can be 26 different letters because there are 26 possible letters in our alphabet. All right, in the second spot, again, since we're allowed to repeat, we still have 26 letter options. And in the third blank, again, because we're allowed to repeat, we can have 26 letter options. All right, so then going to the digits. So we've already talked about this in problem number 12, but there are 10 digits, 0 through 9. And it doesn't say we can't have 0 first. We can have any digits in any order that we want. So there are 10 options for the first digit. Again, since we're allowed to repeat, we have 10 options for the second digit and 10 options for the third digit. So then we would just multiply. I'm sure it gives you like a super huge number, 26 times 26 times 26 times 10 times 10 times 10. Whatever that is. I have a calculator on my phone, but I don't want to use it. You guys can do that. All right. So the second part of so that's the first part. So then the second part says they can't be repeated. All right. So it's very similar. So we'll do the same kind of setup. So we have 1, 2, 3. Scroll down a little bit. All right. And then for the digits, we have 1, 2, 3. All right. So this one, we still have, so these are our letters and these are digits. All right, so for the letter boxes, the first one has 26 letter options because there are 26 letters in the alphabet. But then now it says we're not allowed to repeat. So once we've used one of the letters in the first blank, we can't use that letter in the second blank. So now we only have 25 options left. All right, and the same thing goes for the next blank. It's also a letter. It can't repeat, so it can't be either of the first two. So that means there's only going to be 24 options left for the third letter. All right, and we're just going to do the same thing with digits. So we start with 10 digits. All right, we can't repeat anything. So for the second digit, we're now only going to have 9 options. And for the last digit, we're going to only have 8 options. So then we would multiply all those together, and that would give us that answer. Let's just move this because it's in my way. Let's put it over. Just put it over there somewhere. Doesn't really matter. And there we go. So then you just multiply. So those are the differences. So if you're allowed to repeat, you're always going to have more answers, more options than if you're not allowed to repeat. You're always going to end up with something smaller if you're not allowed to repeat. So that's always kind of a thing to watch out for. But yeah, that's number 13. That was a good one. I can do ones like those. You don't have to really, I don't know. You don't have to think about all the, ugh, my leg's falling asleep. My couch is not very comfortable sitting like this. That's fine. You guys didn't really care. All right. So yeah, that was 13. I seem smart now. I can do more problems. Oh my God, number 12. I hate those problems. Your brain has to work too hard. Okay. So that's our fundamental counting principle. Kind of a fancy way of saying, grouping things. All right, I heard the beep, so that means somebody wants to come into our group. Oh my goodness. All right. Okay. So are we ready to move on to permutations, which is our day 17? Yes, Miss Lastly, we totally are. We're super pumped. Cool. Excellent. Glad to hear it.
Absolutely.
It's okay. I talk to myself during class and might as well talk to myself when I'm at home by myself. I guess technically I'm not by myself. My husband's here. He's just hanging out in the other room. Okay, so just a real quick run through, because I know some people kind of asked before we started, can we just go over really quick permutations versus combinations and their formulas? And yes, absolutely. So permutations are just arrangements of things when the order that you arrange them in matters. All right, so I know that's kind of like vague, but usually this is when like there's an advantage to being in one spot versus another. Like when we were talking about it in the notes videos, we talked about running a race, right? So we said coming in first is different than coming in second. So if say Julie came in first and then Tommy came in second, that's different than if Tommy came in first and Julie came in second. Like those are two different outcomes. So that would be an example of a permutation. So on today's homework, it has like a combination of permutations and combinations like mixed in together, and you have to figure out which one is which. You want to ask yourself, does the order that I'm putting these in matter, or is it just, does it not matter? And so we'll talk about that more when we get to combinations. But that's usually the most challenging part of this, is figuring out which one the problem is that you're working on. So the question that somebody had was specifically for this day was problem number 8. All right, so we'll go over that one. And then, so on your calculator, you don't really need to know the formula for permutation and combinations, because your calculator already has the formula pre-programmed in there for you. So remember, if you want to use your calculator, you're going to hit the math. You're going to go over to probability. And then for permutation, it's number 2. All right, now the actual formula for this is n factorial over n minus r factorial, right? And when we were doing our problem, like the example one together, this one's kind of easy to see visually, like why this formula matters, right? So say you had like, I don't know, how many blanks did I just do? 1, 2, 3, 4, 5, 6. There's 6 blanks here. It's not updating. Oh, there it goes. Okay, so there are 6 blanks here. All right, we'll say there's 6, I don't know, dogs in a race. I'm not really sure. Who cares, right? All right. Now, what if I don't care about all 6 dogs that are finishing this race? What if I only care about the top 3 dogs, like first, second, and third, right? So if I only actually care about these first 3 dogs, what we have to do is divide by the numbers that are remaining, right? So we would divide by like the last 3 spots, because then they would cancel and you would just be left with like those top 3 spots. Well, that's what this formula does. All right, so you don't have to know the formula because like I said, it's in your calculator, it's programmed in there for you guys. But yeah, so this is the formula for permutation. So this is NPR. Okay, so if we look at problem number 8, all right, so it says a group of 25 people are going to run a race. So that means that N is 25. We have 25 people in like the whole pool of people. All right, so then it says there's a unique prize for first, second, and third. Hold on, I hear the beeping, which means people are trying to come in. Why are they trying to come up in here so late? Okay. All right, so it says there's a unique prize for first, second, and third place. So we only care about first, second, and third. So our R value is 3. We only care about the top 3 people. right, so then it wants to know how many possible ways you could give out prizes. All right, so because first is different than second, which is different than third, the order that people finish matters. All right, like I said, somebody finishing first versus finishing in second is 2 different outcomes. So this is definitely a permutation problem. So we would go to our calculator, we would type in 25 and then P3. And then see what we got. So I think I have this one written down somewhere, so I can look up the answers. Blah blah blah. Yes, this is one beautiful number, 1081575. There we go. All right. Now I know we went over this in the video notes for this section, but just a reminder. So if you have the newer calculator, you want to go straight to math, probability, and then hit number 2, and it's gonna pop up with like a box and then a P and then a box. You just have to use the arrow buttons on your calculator to scroll backwards, fill in the first box, and then scroll forward, fill in the second box, and then just hit enter and it works. If you have one of the older calculators, yours is going to, when you type in your buttons, you have to hit the end number first. So what you would do is you would type in 25, and then you would go to math, probability number 2, and it would then do NPR. So it's going to like show that thing, and then you type in the R value of 3 and then hit enter, and then you'll get your same answer of 1081575. All right, so newer calculator, you do math first. Older calculator, you have to hit the first number first and then go to math, and then you type in the number 3. That's how they work. All right, that was the only question for this day. Was there any other questions you guys want to go over for day number 17 before we move on to day number 18?
For problem 6, would it just be 5P5?
Award ribbons for first place to 5th place to the top 5 dogs in a dog show. Yeah, it would just be 5P5. Because it doesn't say, I'm assuming, it doesn't really say that there are more than 5 dogs. So yeah, I would do 5P5 because you're giving prizes to the top 5.
Miss Latson.
Yes.
On number 8, is the P the same thing as NPR?
Yes, the NPR. Yeah.
Oh, okay, all right.
Yeah, just with the top one is with a newer calculator. It's not going to pop up and have NPR. It's going to be a P with a box in the front and a box like second. So you fill in the numbers. On the older calculator, it actually, when you hit that button, it shows up as NPR, and you don't fill in the N and the R. It just stays like that. So that's what the 2 calculators are going to look like. They're a little different.
So when
okay, on this problem, I did 25 NPR 3, and I got 13,800.
Oh, yep, probably because I just copied down the wrong day. That was from a different day.
All right, gotcha.
I got that too. It scared me.
Sorry, I don't have.
You scared me, Miss Leslie.
Oh.
Yeah, I was like, what the heck's going on around here?
Yeah, it says it's not even the same problem. I don't even know what I was doing. I don't know. What did we get? It was not even this.
I had
just going
1081 thing for some reason as well, but then like I actually did the work and it was everything.
Yeah, no, I definitely it's not even the same problem. It's definitely a different problem. I just copied out the answer for something different. So whatever you guys said it was, what did you say it was?
13,800.
13,800. Cool. That's probably the right answer.
I like it.
P and C.
What the difference between P and C? Okay. So P stands for permutation, which means the order matters, right? So let's just talk about this. So I'm just gonna go off on this side here. because order mattering versus not mattering sometimes throws people off. Okay, so let's say we have A, B, C, and D. Okay, we just have those. We have those 4 letters. All right. Now, if I say, how many different arrangements can I make with the letters? Well, that means that I want to arrange them differently, right? So that means that B, A, C, D is different than A, B, C, D, because I'm saying that the order matters, right? So the letters in different orders is important. So I have 4 letters, right? So if I wanted to know how many different arrangements there were, this is a permutation problem. So I would use 4P4, and this would give me a number of ways that I could arrange my things. So this is going to be like 4 factorial, I think. So 4 times 3 is 12, 24. 24, I think, is what you get here. If you do 4P4, I think you get 24. All right. Now, this is a permutation way of thinking. C stands for combination, and combination just wants to know how many ways can we like pick these 4 letters out of like a hat. We don't really care the order that they're in. We just want to know how many 4-letter groups could I make. Well, if I only have 4 letters, then how many 4-letter groupings could I make? 1. Because I don't care what order they're in. I just want 4 letters that are grouped together. Well, if I only have 4 letters to pick from, there's only one way to group them. That would be a combination way of thinking, right? So if I have 4 letters and I just want to know how many not arrangements, but how many groups could I have, that would be for C4, right? Because I'm saying I don't care how they're arranged. I just want to know how many groups of them can I make. And this would give you just like 1. So this is more of a combination way of thinking, right? So I don't really care how they're arranged. I just want 4. I just need 4 letters out of the 4 letters given. Well, there's only one option. So that's the difference. So P stands for permutation. And when you think permutation, I want you guys to think the order that you're arranging the objects in matters. All right. C stands for combination. And I just want you to think we're just picking that many of something. We don't care the order that they're in. Order is not important for these problems. We just want how many groups. So another way of thinking of this is like a very common problem. I think there's probably some of them on today's. Honestly, I don't know. I haven't looked at it yet. If we're being real, you can thank Miss Markert a lot because Miss Lastly is not doing really anything, which I know is terrible, but it is what it is. So yeah. So a very common problem is thinking of a group of people and you want to make a committee. So if we have 10 people, all right, and we want a committee of 5. Committee of 5. Okay. All right, so 10 people, I'm going to make a committee of 5. Does it matter the order that I pick the people in this committee? Or does it just matter that I choose 5 people out of the 10? Well, it doesn't really matter the order, right? I'm not saying that there's anything cool about being picked first, right? I'm just saying we want 5 people out of the 10. This is a combination problem because the order that I pick the people is irrelevant. They're just going to be 5 people making a committee. So I would say this is combination, right? So I would do 10 people. I'm choosing 5 of them. And that's going to give me my answer. Now, if it was a permutation problem, it would say something like this. I have 10 people. I need to pick 5 to be the president, the vice president, the secretary, the treasurer, and the historian. I don't know, whatever, right? Well, then it does matter because, I don't know, Joe being the president is different than Joe being the treasurer. So inside the committee, they have special significant pieces. That then makes the problem a permutation problem, because the order that they're being selected for this committee, right, is important, because we'll say like the first person gets to be president, the second person gets to be vice president, and so on and so forth. That changes it to a permutation problem. All right, so that's the difference. So when we go over to day's homework, which, what is that, day 19, and there's definitely a lot of questions on day 19, we're going to look at and talk about combination versus permutation and how do we know which one if they're all just kind of thrown together. Now, I don't know if this was somebody from one of the classes, because my YouTube, my super popular YouTube channel is not private. And so one of the comments was like, can they be both? Well, no, they can't be both. It's either a combination or a permutation. There's no possible way that they could be a both. Like, that's not a thing. It's one or the other, right? But yeah, so let's go on to day 18, which was strictly combinations, and answer that question. Yeah.
The NPR, is NPR interchangeable with n factorial over n minus r factorial?
Yes, that is the formula. So when you type into your calculator NPR, it knows the formula is n factorial over n minus r factorial. Like, that is the formula for NPR.
So I could just do that instead if it was more convenient?
Sure.
All right.
Yep. Like, say, like, I only have my cell phone right now is my only calculator. So if I were to do these, I would have to use the formula because my calculator doesn't know what NPR, it doesn't have it in there. So yeah, so if you just have like a normal calculator, like you don't have a graphing one with you right now, then yes, the formula, right? This formula right here, right? This is the NPR formula that if you have a calculator and want to use it, great. But if you don't have one, that's the formula that it goes with. Okay, so combinations. All right, so our combination formula is a little bit more intense than permutations, but it's the exact same formula we were using last week for the binomial theorem. So let's just write there. So NCR. Now, sometimes when you see NCR, there it is. Like if you go into college and you do like any kind of probability class, or even sometimes in depending on your calculus teacher, you don't really get too much into this until the very end of that first year of calculus / the beginning of the second year of calculus. So this is kind of getting you guys into like the more advanced pieces of calc. Some teachers also write it like this, where it's like parentheses and then you have n over top of r. That is the same thing. So NCR, sometimes you'll also see it written with the parentheses n over r. I wouldn't probably write it like that. I'm probably going to stick to this method just because that's what our calculator shows us. But just know that those two things do mean the same thing. Now, there's no shorthand like that for permutation, not that I've seen or / remember. It strictly is just used for combinations. All right, and then the formula for this one is n factorial over n minus r factorial r factorial. So it's pretty similar. All right, you just have this extra r factorial on the outside. All right, and remember, like I said, this is what we were using last week for our binomial theorem. Okay, so that's our formula for combinations, right? So this would be C for combination. Ta-da! All right, so let me scroll back up to the top really quick. So we wanted to do number 7 on this day. Okay. So number 7, a college needs 2 additional faculty members, a chemist and a statistician. A statistician. Cool. All right. In how many ways can these positions be filled if there are 3 applicants for chemistry and 8 applicants for statistics? Okay, so this one's kind of a mix. Again, this is a problem that I probably would have left out if I remembered that it was on here, because we didn't really talk about and versus or problems. I know you guys saw and or in geometry, but that was a really long time ago. And that was something that I did kind of throw out, but we can still talk about this in its individual pieces. And then I'll show you the final answer. But yeah, so this is a problem that kind of could be thrown out, because I wouldn't give you one like this on the checkpoint where you have 2 different things that you're combining together. But yeah, so we'll talk about this one. So it says, so first off, chemistry. So first we'll just talk about our chemistry teachers. So it says we have 3 applicants and we only need 1, right? We're only picking 1 chemistry teacher. So it would be 3 and we're choosing 1. We're only choosing 1. Order is not important, right? It doesn't matter the order that we pick people in. And even if you did this as a permutation problem, you actually would get the exact same answer, because 3 choose 1 is the same as 3p1. And if you look at the formula, remember the only difference is the r factorial. Well, r in this case is 1. 1 factorial is just 1. So it would be the same thing. But just know that order doesn't matter. We're just picking 1 person out of a group. Order is not really relevant for this one. All right, so we would say 3C1. That's how many different options we have for picking a chemistry teacher. All right, and I think, what is this? Just 3. I think we just get 3. All right, so then we want to look at our statistics stats teacher, and it says there are 8 applicants, and again, we're choosing just 1 of them. So we have 8, choose 1, so 8. All right. Now, to find the total answer, this is an and problem. You don't need to know this. I'm just going, all you would need to know for this week's checkpoint or next week's checkpoint or anything that we're going to do this year in this class is what I've showed you right now. But to actually answer the final problem, this says we need a chemist and a statistician. Anytime you see and in problems when we're doing like combinations of groups, it means it wants you to multiply the 2 answers together. So we would do 3 times 8 to get a total of 24 different options for this one. So the final answer would have been 24. All right, so right here, anytime you see that and word, it means it wants you to multiply. Okay. Again, you don't need to know that for this year. I cut that part out. This problem just ended up making it through. Again, I'm pretty positive you guys saw that in geometry. So maybe some of you guys picked up on it. I don't know, maybe not. Okay, so that was the only question people had on this day number, whatever this is, 18. Is there any other ones or anything else you want to talk about? Strictly combinations before we move on to day 19 where everything is mixed. Okay, cool. All right, so moving on then. Scroll. Okay, so day number 19. There were quite a few for day number 19. So we have 1, 2, and 4. So 1, 2, and 4. Okay, perfect. So let's check these out. Okay, so number 1. So the first question we have to ask ourselves for any of these is this a permutation or a combination? Now, also in here, I know it doesn't say permutation, it just says permutations and combinations, but some of these might just be the fundamental counting principle where you're just kind of ordering things up. And actually, I think, I don't want to guess, but I think that might be number 1. It's just actually just a fundamental counting principle problem, but let's look at it. So as we have a group of 10 people at a picnic. There are 4 children and 6 adults. If the children line up first to get food, followed by the adults, in how many ways can the 10 people line up? So, yes, this is just for I would do this one just like I would with the problems from day 16 as like the fundamental counting principle, where I kind of like line up all of my events and multiply at the end. Now you probably could do permutation combination kind of technique for this. I'm not going to do that, but we'll talk through it. I can show you. There are definitely two different ways you can think through this one. So we'll do it both ways. So if you're just thinking, how many ways can I arrange this? This is kind of how I would approach it. This is more of like a just intuitive thinking problem more than like a use a formula for me problem. So it says children line up first. So I'm going to do children in orange blanks. 1, 2, 3, 4 children. And then adults, there are 6. So 1, 2, 3, 4, 5, 6. All right. And I'm just going to multiply each piece together. Okay. So for children, so there are 4 children. So there are 4 options for the first kid to line up. All right. Once one person lines up, that means there are only 3 options left, and then 2 options left, and then the last kid. All right. So we have 4 factorial there. All right, and then we have adults. So we have 6 adults in the first spot. Since one of them is now already lined up, we have 5 options left for the second spot to line up, and then 4, 3, 2, and then the last adult. So basically what this looks like is 4 factorial times 6 factorial. And I think I probably have this answer somewhere. Let me just flip. Yes, I do. 17 to 80. 17 to 80. All right, so that's kind of just like thinking through the problem. If you wanted to do this more of like combination or permutation, you would think of it like this. So first off, in this problem, does the order that they line up matter? Well, yes, because it wants to know how many ways can the 10 people line up. All right, so anytime it's like how many different ways or like arrangements, that means order matters. All right, so Susie lining up first is different than Susie lining up second. All right, so order matters here. So this would be a permutation problem. So for the children, I just spelled children wrong, but we're just gonna pretend like I didn't. No worries. You would do for children, for P, and we are picking all 4 of them. So for P4 would be what we would write. All right. And then we would do adult separately. All right, so we have 6 adults, 6. Order matters. Again, we already talked about, we want to know the ways that they can line up. So order matters, so permutation. And we are picking all 6 adults, that everybody gets to line up and get food. All right, because it says, blah, blah, blah. The word and is in here somewhere. So we have 4 children and 6 adults. That tells us that we're going to multiply those 2 answers together. All right, so we would end up with the same thing, 17 to 80. All right, so you could do permutation for this one. I think it makes a little bit more visual sense, maybe to do like the different events that we have kind of going on, like the children lining up first and then the adults lining up second. But it doesn't really matter. You're going to get the same answer either way. All right, I heard somebody try and come in. All right, cool, admit. All right, one done. There it is. Okay. How do we feel on number 1? Yay, cool. Good, perfect. Okay, number 2, how many license plates begin with 2 letters followed by 4 digits? All right, so this is another fundamental counting principle one. So this one, I wouldn't really do as, I mean, you could do it with permutations if you wanted to. I would probably not do it with permutations. I would probably do it using the blanks and filling it in, but it's up to you. I'll do it both ways. All right, so the first way, I'm just gonna use the blanks. All right, so license plates that begin with 2 letters followed by 4 digits. Okay, so the first option, 2 letters followed by 4 digits. All right, so then you say, okay, how many letters are in the alphabet? 26. All right. Now does it say if I can repeat or not? How many license plates begin with 2 letters followed by 4 digits or begin with 3 digits? Assume that no letter or digits are repeated. So I'm not allowed to repeat. So if I have 26 options for my first blank, I only have 25 options for my second blank. All right, now I can go to my digits. All right, I have 10 digits to begin with, 0 through 9. All right, but then I have one less each time because I can't repeat. So then I get this, and I also have this number. It's a really big number. It's wonderful. 327. 3276000. Beautiful. All right, so that's the first method. All right, you could also, again, use permutations. So the second method for this problem would be to, like I said, use the permutation method. So for the first two blanks, I have 26 total letters, and I'm picking 2 of them. And yes, this would be permutation because the order that you arrange them in matters, right? Somebody having license plate CA versus license plate AC is a different license plate. So order matters. All right. So that would be for my letters, and then times. So then I have my digits. So I have 10 digits to pick from. And again, permutation because order is important. And I'm choosing 4. Or I'm picking 4 of them. All right, so, and it's and, because I have digits, or sorry, letters and digits. So I'm going to multiply, and I will get the same thing, 3276000. All right, now I know I only answered the first part of that question, but I think you guys can do the second part because it's the same exact thing, right? The second part says it has 3 digits followed by 3 letters. So you would just do digits for the first 3 blanks and then letters for the second 3 blanks. It's the same thing. All right. It's basically 2 problems in 1 problem. All right. But that's how you would do it. So you either have, you can do the fundamental counting principle where you have like the different events, like the different spots, placeholders, I guess you can think of them, or you could do permutations. You're going to get the same answer. All right, moving on to number 4. So it says, just before each Supreme Court session, each of the 9 justices shakes hands once with every other justice. How many handshakes take place? This is a good problem. Okay, so the question you have to ask yourself is, does order matter? Does it matter if I shake Justin's hand or if Justin shakes my hand?
No.
No, it doesn't matter. As long as we shake each other's hand, it doesn't matter the order that we shook hands in. So, combination or permutation? Combination, because order doesn't matter. So first, I know that this is a combination problem. Okay. Now, here's the second question. This one is a little bit not as intuitive. All right. So it says each person shakes hands with one other person. So how many groupings are you going to have? So like we know we have 9, and it's 9C something. What is the R value for a problem like this? Well, how many people does it take to shake hands? 2, right? So it's 9 choose 2. All right, so this one's definitely kind of funky. All right, so it's a combination because the order that people are shaking hands in doesn't matter. And it's 2 for our R value because a handshake happens with 2 people. So you're seeing how many different groupings of 2 are there. All right, so then we would say whatever, I think this is 36. Now there is a different way to do this problem. This is one of the problems where I get really funky answers each time. But this I think is probably the most straightforward way to look at a problem like this. So anytime you're doing handshakes, or there's another one, I don't know if it's on this sheet or if it's on another sheet that I have, or it's probably going to be on the checkpoints. So that's probably what I'm saving it for. But giving someone it was like a Valentine's Day problem. So I definitely think that you guys are going to see this because I'm pretty sure it's on like the quiz for this part. So you just kind of have an extra heads up. I think it's like there's like a class of 32 students and each student gives someone a Valentine or something like that. I don't remember the exact wording and I can't find the problem right now, but it would be the same kind of thing. Like exchanging cards is like there's 2 people it takes to exchange them. So even though it doesn't say specifically like the group, we're picking a group of 2, just know that if it's something between someone and one other person, it is a grouping of 2. So your R value is 2. So I like that one, the handshake one. That one's kind of interesting. But yeah, so we did those 3. Are there any other ones that you guys want to talk about from?
Can you do 5 or 7?
Yeah, let's see. All right, so number 5. So we have a group of 45 people are going to run a race. All right, so first up, I know my N value is 45. All right, it says the top 3 runners advance to the next round. Okay, top 3 runners advance to the next round. Does it matter the order that these runners finish in, or does it just matter that they were the top 3? What do you guys think? Does the order matter that they finish in, or does it just matter if they're top 3?
Just matters that they're top 3.
All right, just matters that they're top 3. So since it just matters that we just want to pick the top 3, we're going to say that this is a combination problem because order is not important. All right, so this is a combination. So we now know that it's 45C. All right, and since we're picking 3, we want a group of 3. Our R value is 3. So we have 45, choose 3. And I think I have this one written down somewhere. Who knows? Maybe I do, maybe I don't. No one really knows in the moment. Nope, I don't have this one written down. Yes, I do. No, I don't. Nope, so it's some big number. I don't know what it is. I don't have the number in front of me. And I don't want to use my phone calculator. I'm lazy.
Are you doing day 19?
Yeah.
My day 19 is different. My 5, 7, and 8 are, or no, 5, 6, 7 are different.
Really?
Same.
Yeah.
Same here.
Same.
Same. Okay. All right. Well,
I think it got updated earlier this week, so maybe go back and look. There were problems on there that shouldn't have been on there.
okay. So
Okay. Because the one I was asking about was like regarding probability or something, and I was like,
Yeah, when I made the worksheet, I missed the probability question, so I fixed it earlier this week.
yeah.
okay, I'll print up the new one.
Yeah, at the beginning of the week, we kind of talked about it, me and Miss Marker did, and we really just wanted to get the very basics. So we took out a lot of stuff that I usually have in for this unit, just because it would have been really, it's something that we need to be together for, to talk about like in class a lot more than just once a week. So we kind of took it out. So anything that says like the probability, or like there was a lot that were like and or problems that we would have had in like originally, we took all of those out. So if you see, sorry, I'm like really uncomfortable right now. That was probably not the best visual, moving my foot. Anyways, yeah, so any of those problems, if you guys saw them, like if you looked at them at the very beginning of the week, just ignore them because we took that out. It would have been too hard to kind of do this virtual way. So you can ignore that. It's okay.
Wait.
Yes.
Okay, so I have a question. How would 5 be a permutation problem then? Like, how would you change that to make it not combination?
Okay, so if I said number 5, a group of 45 people are going to run a race, how many ways can I award first, second, and third? That would be a permutation problem.
Oh, okay, because it matters who's in first, second, and third, or yeah.
Yes, absolutely.
And
Okay.
then how would you do it? How would you do the problem if it was permutation?
So if it said, so let's just say, ignore these rules. Okay, so now we're changing the problem. So if I said, how many ways can you, that is really ugly handwriting. It doesn't matter. You award first, second, third. All right, so first you have to change the problem because as is, problem number 5 is a combination problem. But an example of it as a permutation would be if I cross off that second sentence and put in there, how many ways can you award first, second, and third? That then becomes a permutation problem. So let's just do like this, so we can get a color code visual happening. Okay, so in orange, I'm doing the permutation. So now, since order matters, because I'm awarding first, second, and third, it becomes permutation. So the only difference, once you figure out which one it is that instead of doing 45C3, you're going to do 45P3. 45P3. And get whatever that equals. All right, so the numbers stay the same. It's still 45 out of the whole group, and you're picking 3 of them. Just combination, we don't care what order they're picked. We just want 3. Permutation, we do care about the order because we're giving them prizes for being in different positions. So order matters. So we would do 45P3 and whatever number that gives you. You will definitely get 2 different numbers. Remember, the formulas are different. Combination formula, n factorial, n minus r factorial, r factorial. Permutation formula, n factorial, n minus r factorial. So they are different formulas. All right. So yeah, so that's what it looks like as a combination, which is how it was written. And then in the yellow or orange or whatever color that is, that would be what it would look like as a permutation. So good question, like seeing them next to each other. All right, what else? Well, you guys got any other questions? Because that was all that I had. Those were all the questions that people had this week. No? Okay. All right. So if that is all of the questions, I don't really have anything new to add. We didn't really learn too much during our staff meeting yesterday. Like last week we talked about a lot. This week we didn't really talk about too much. The good news is that you know how I made that like graphic organizer that I put at like the top of the thing so you guys could like see what you have to do each day. A lot of other teachers are thinking of doing that also for their class. So that could be kind of nice. You could have other classes that also have that kind of like day-by-day breakdown and like what you need to do for the semester kind of thing. So that could be helpful for you guys. That was really all we talked about in our staff meeting. Everything else was kind of like the same stuff that we talked about last week during our live stream. So nothing really new has changed. Grades are still going to be A or incomplete. Yeah. Most important thing is everybody's going to get an A. It just depends on what your path to getting an A is going to look like. So for this class, it's either you kind of stay up with the class, get everything done as you're supposed to, do a relatively good job on your checkpoint, and then you're done June 5th. The second, and then you get your A. The second option is you don't really stay caught up with the class, you kind of fall behind, maybe you don't do some of your checkpoints, and then by June 5th, if you still aren't meeting like the C-, then you'll have some extra work to do and get turned in, and once you do that, then you get your A. So I know a lot of you guys are really stressing, and I know some teachers are really not getting it, but just so you know, we have been told the only way to get an incomplete is if you absolutely do nothing during this time that we're out. So as long as you're trying to participate, you're doing the best you can. Like for this class, you're doing the checkpoints, you're, asking questions during our live stream, you're attending the live stream. Like you're not even going to have to work. You're going to get the A, right? So I know some of you guys last week were talking about teachers who were giving you like 6 and 7 hours worth of homework a day. Like that's too much. And that was kind of the main focus of this week's staff meeting, was making sure teachers weren't overloading you guys. because a lot of the feedback has been like, my kid is really stressed. Like, parents have been emailing constantly saying, like, to Mr. Weinkoop, saying like, it's too much, my kids are stressed, like I can't handle it, blah, 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 all this other stuff. So his main message was just like to try and make things easy, you know, show them how they can be successful and, you know, what they need to do to get the A, but just ultimately know, as long as you're participating week to week and you're doing a little bit all the time, you're gonna pass, guys. So I know a lot of you guys want to like do the best you can, and that's great, because a lot of you do take classes where it builds, where you, like, for instance, this class, like if I was teaching a class like statistics where it didn't really matter what you did next year, like statistics was just its own class, it wouldn't be as important to do the material because there's nothing that builds. But since I know that most of you guys are heading to AP Calc and Calculus next year, and this material is relevant for your class, I do want to kind of have you guys exposed to the material more for the future. So if you think about classes that you're taking where it builds, especially like your English classes kind of build on each other. I don't know about science. I don't really know anything about science. Maybe they build, I don't know. Chemistry, I don't know. Most of you guys are like in chemistry and it seems like it's like its own subject, but like just think about your classes that kind of like build on each other. Those ones are definitely probably going to push you to do more work, whereas ones that kind of stand alone, like Mr. Weinkoop really wants you guys to not be overworked. So if you are feeling overwhelmed, if you do feel overworked, reach out to your teachers and let them know. I mean, that goes for this class too. Like, I'm trying to be very lenient. Like, I know some of you guys have fallen behind on your checkpoints, and ultimately it's okay. I do want you to try your best to get caught up, and I want you to try your best to do stuff. But I mean, I get it. Everyone is stressed right now. Everyone is really having a hard time finding like the reason to get out of bed. Like, I know there are days where the only time I'm out of bed is when me and Miss Markert are filming your daily videos, which I know is really sad, but it is what it is. Like, what's the point, right? And we're not allowed to go outside. We're not allowed to do anything. So what's the point of even, you know, putting on pants that day? But yeah, so my main thing is, if you are feeling overworked, if you're feeling extra stressed, you need to talk to your teachers and say, hey, this is too much. I need to take a break. I need something because this is too much for me. And supposedly all teachers are working towards being understanding. So yeah, so that was our main takeaway from our staff meeting yesterday. Wasn't super exciting, but it was kind of just, some teachers are doing more than other teachers right now, and they need to kind of calm down. I'm sure you guys are feeling that. So I don't know, hopefully it'll be better going forward in some of your classes, maybe not, I don't know, but they're supposed to be nicer to you guys, I guess is the takeaway. Yeah, so any other like comments or things that you guys want to share before we call it quits for the day?
For some of the questions where the variables were wrong, like we used x instead of n, will you correct those, or are they just going to stay the way they are in the gradebook?
No, I already fixed them.
Oh, okay.
Yeah, I already went back and accepted them. So sometimes people emailed me to let me know, and that's good. So if you like think that your answer is right but it got marked wrong because you did something weird, just email me and I'll look at it. And if it is right, I'll go in and add it as a correct answer. So some of you guys submitted it and then it told you it was wrong, but I've already gone back and fixed it before I put it in the grade book. So yeah, so just keep doing that. So if you think you have one that should have been right but it got marked wrong, just email me and I'll go back and fix it. It won't show up to you, like it'll just say like your original grade is what you'll see, but when I go back and put it in the grade book, when I print out the final like Excel spreadsheet or whatever, it'll have it as updated. It fixes the grade. Yeah, good question. Any other questions or comments before we sign off?
If we miss, this is just like in general, but if we miss a few assignments, does that mean we get an incomplete in any class, or do you have to miss like a lot of stuff?
So the message that they kind of were talking about yesterday is if you're just missing like one or two things, your teachers are going to have so in order to give an incomplete, we have to have evidence that you haven't done anything while we've been out. or maybe you've done like one thing and then didn't do anything else. So it's harder for us to give incompletes. The main thing is they want everybody to get an A. So the only way you can get an incomplete is if your teacher can prove that you haven't done anything while we've been out and you've had access to the material while we've been out. So let's just say this class. So for this class, let's say we get to the June 5th and you have only done 2 checkpoints. You would be failing because you would have a lot of zeros. So what I would then do is to email you, say, hey, you haven't done your checkpoints. Here's some extra work. And just in case you guys are kind of curious, like I don't want you to do this, but I'm just saying, if this is you, it's going to be a lot of remedial stuff. So it's going to be like practice from maybe first semester, because I know you were there and you should have learned first semester. And it's probably going to be some Algebra 2 practice as well. You'll have to do it. And if you do it and you turn it in, you get an A. So like that's what I'm planning on doing for this class. Now, most of you guys are just doing your checkpoints anyways. Like some of them aren't good grades. And honestly, I know I'm putting in the grade book, like the actual grade or whatever, but as long as you're trying each week, that's not going to be a person that I'm worried about on getting an incomplete. But the main thing is you literally have to do nothing, like consistently the whole time. Like if you're coming in and you're doing like, say it's English, I'm just making this up. Say like each week in English, you're supposed to do like a short essay. I don't know. If you did like maybe like the first essay and then didn't do anything else, that they would probably be able to give you an incomplete. But say you did like the first essay and then like, I don't know, a couple weeks later you did another essay and then a couple weeks later you did another essay, they would probably have a hard time giving you the incomplete because you were logging on at intervals at least maybe. And doing it. Now, I know some teachers are definitely more hardcore than others, so you guys know your teachers better than I do, but the main message is if they're doing at least something while we're out, we are not supposed to give an incomplete. It's kind of reserved for kids who just blow it off, like don't do anything, I guess. I think that was Margaret. Did that answer your question? It might not have been.
Yeah, that was helpful. Thank you.
Okay. Any other questions you guys have? Like, even if you want to, I mean, I don't mind talking about this. I'm actually going to stop recording in case, like, yeah, we'll just stop recording.